does the given table represent a linear function? Well, to figure that out, we could take the points from this table, plot them on a coordinate plane, and connect them, then see if they make a straight line. Remember, linear functions have graphs that are straight lines. But what if we don't want to use a graph? What if we just want to look at the table and decide? Well, we can do that. In order to simply use the table, we need to recall what we know about the tables of linear functions. So let's go ahead and start off by looking at a different table of values. Let's say we have the x values 1, 2, 3, and 4, and the respective y values are 0, 2, 4, and 6. Great! Now, to see if this is a linear function, we need to look at the changes in the x values and the y values. In order to be a linear function, the x values have to have a constant rate of change, and the y values have to have a constant rate of change. So let's look at the x values. How can we get from each x value to the next? Well, to get from 1 to 2, we could add 1. To get from 2 to 3, we could add 1. And to get from 3 to 4, we add 1. Each time we want to get the next x value, we simply add 1. This indicates that x has a constant rate of change. We're adding a constant amount each time. Now do the same thing with the y values. Well, how can we get from 0 to 2? We could add 2. If we want to get from 2 to 4, we could add 2. And to go from 4 to 6, we could add 2. Notice, each time we're changing the x value by 1, our y value is also changing at a constant amount. We're adding 2 each time. That means that y also has a constant rate of change. Since both x and y have a constant amount of change, that means that this table represents a linear function. Cool! Now, to get an even better understanding, let's look at another table of values. Let's say these x values are 3, 6, 9, and 12. And the respective y values can be, let's go with 1, 4, 5, and 7. That'll do. Now, to see if this represents a linear function, we need to look for those constant rates of change. So let's check the x values. Well, to go from 3 to 6, we could add 3. To go from 6 to 9, we could add 3. And to go from 9 to 12, we could add 3. So to get each x value, we simply need to add 3 to the previous x value. That means x is increasing at a constant amount. We have a constant rate of change. But what about those y values? Well, let's see. To go from 1 to 4, we could add 3. To go from 4 to 5, we could add 1. And to go from 5 to 7, we could add 2. And take a look at that. Each x value is increasing at a constant amount. So, we're having the same change to x each time. But we don't have a constant amount of change for each y value. Here we're adding 3 to get the next y value. Here we're adding 1, and here we're adding 2. X and y both need to have constant amounts of change in order for this to be a linear function. So here, this table does not represent a linear function. If we plot these points and connect them, we will not get a straight line. Now that we know a little bit more about identifying tables that represent linear functions, let's take a look back at our table. Let's check out the x values. Well, first we want to go from 1 to 2. To do that, we could add 1. Now what about going from 2 to 3? Well, there we could add 1. And how about 3 to 4? Again, we could add 1. Each time to get the new x value, we simply need to add 1 to the previous x value. So we can see that x has a constant rate of change. But what about the y values? Well, let's take a look. Here, y needs to go from 12 to 7. Well, to do that, we could subtract 5. Now what about going from 7 to 4? There we could subtract 3. And from 4 to 3, we could subtract 1. Now take a look at that. As our x values are increasing, our y values are decreasing. Now that's okay. We could have a linear function with those characteristics. But we need to make sure that x and y each have a constant amount of change. We already know that x does. But y looks like it changes a different amount each time. Here we subtract 5 to get the new y value. Here we subtract 3, and here we subtract 1. We're subtracting a different amount each time. That means that those y values do not have a constant rate of change. And since those y values do not have a constant rate of change, we know the answer to this question. No, this table does not represent a linear function. If we plot these points and connect them, we will not get a straight line.